Hello. In this video, we're going to cover a brief review of ratios, proportions, and percents. So let's start off with a ratio. So a ratio is a fraction that compares two quantities. Right, so we'll have, for example, quantity A over quantity B. Okay, so that's it. That's what a ratio is. Examples that are popular, common in everyday life. You could see miles per hour. That's miles over hours. You could see dollars per hour. You could see dollars over years. These are all examples of ratios. Okay, so and to give a specific example, you could have something like 40 miles per hour. We write that as 40 miles over 1 hour, if you were to write it kind of in a mathematical sense. And then you can go through and use a ratio, for example, like 40 miles per hour. If you want to go through and figure out how far you would travel in 7 hours, you would go through and you would multiply to get a 7 here instead of a 1. So to do that, you'd multiply the bottom by 7, and so you'd multiply the top by 7 as well. And if you do that, you can use a ratio to get the fact that there's 280 miles over 7 hours. Another way to go through and solve the same problem is with what's called a proportion. So proportions are when you take two ratios and you set them equal. So all right, so how could we go through and solve that same example with proportions? What you could do is you could have 40 miles per 1 hour. And then you could set that equal to X miles over 7 hours. Okay, and then you could do what's called cross multiplying. And so if you do that, we'll get 1 times X, it gives us X. 40 times 7 gives us 280. And so we can go through and solve for the fact that you get 280 miles. Okay, so these are two different ways to go through and use ratios. One, you just end up multiplying by whatever quantity you'd want to get. You could do the same thing for top or bottom, by the way, with this. So let's say if you wanted to know how long it would take to go 400 miles. So to get from 40 to 400, you'd multiply the top by 10, and so you'd multiply the bottom by 10 as well. And so it'd take 10 hours. So that's one way to go through, simple way to go through and use ratios is just to multiply by whatever number you want to get in either the numerator or the denominator. And then you can read the other one to figure out the information you're looking for. And then you could do something very similar with proportions where you just go through and you take two ratios and you set them equal. Okay. So that gives us just a quick little background on ratios and proportions. We're gonna do percents in a bit, but first, what we want to do to work our way up to percents is to talk about ratios. So ratios are sometimes written as a part over a whole. Okay, so where you'd put the part or some portion of the whole in the numerator, and then you'd put the whole in the denominator. So what do I mean by that? Let me give you an example. So let's say you go through and you have 5 men that you're going through and you're collecting data from, and let's say 2 of the men have long hair. So what you could do is you could say a ratio would be that there are 2 men with long hair over 5 total men. Okay, and so that gives us that's a ratio, right? So we have a quantity, in the numerator and a quantity in the denominator. Except this time, instead of having 2 unrelated, or things that seem unrelated anyway, like we have miles and hours, instead we're looking at 2 things that are directly related. So this one is kind of the entirety of the data set that you're collecting, and then this is the portion of that meets the criteria that's described. You could go through and you could have, say, 7 women always wear seatbelts. So that's a reference to this week's section that we're going to cover. Divided by or over 10 total women. So you can see again, we have some portion of, you've got the total in the bottom, and then you've got some portion that meets a criteria in the top. Okay, and now everything that we just said about ratios and about proportions still applies to these ratios that are a part over a whole. You could still go through and say, you've got 2 men with long hair over 5 total men. And let's say if you were to go through and you wanted to know, all right, well, if I had, let's say I went through and I had 30 total men, how many would have long hair? So you can go through and you could solve this using a proportion by putting X in the top here. So you've got 2 men with long hair versus out of a total of men, out of 5 total men. And you want to know how many men would have long hair if we had 30 total men. And so if you go through again, you can do the cross multiplying here. You'll get 60 equals 5X. And then you can solve for X by dividing both sides by 5. And we get 12 equals X. And so 12, you'd have 12 men with long hair out of 30 total men would be the same ratio as 2 men with long hair per 5 total men. Okay, and just like the other, you could use the other method too here. If you wanted 30, you could multiply the bottom and top by 6, and so 2 times 6 does give us the 12. It's like a shortcut. Okay. All right, so that's ratios. We did a couple examples with proportions. Now let's go through and talk about percents. So a percent is or at least the way that we're going to introduce it, a percent is a part over whole ratio where the whole is 100. Okay. So for example, so if you say 70%, 70% equals 70 over 100. All right, so 70% is just the shorthand version of this. So a percent is a ratio. This is the percent, 70 over 100. And then we can go through and use the percent symbol here to just shorthand it to 70%. All right, and this is always true, right? So if someone says 3%, this means the same thing as 3 over 100. If someone says 1.2%, 1.2% is 1.2 over 100. Okay, so in every case, whenever someone says percent, it's always that quantity over 100. And actually, if you look at the term itself and you just kind of split it apart, you have per, which is another term that we use for the division symbol, and then you have cent. and cent is just the shorthand way of writing 100. Okay. Percents can also be written as decimals. Okay, and so the way that you can get there is if you go through and you start off with 70% equals 70 over 100, and then you break out a calculator and you actually divide. You actually use the division, use the fraction here. You interpret that as the division symbol, and then you go through and plug this into a calculator. You're going to get 0.70, and then if you just kind of skip over this, get rid of this middle piece here. We can say that 70% equals 0.70. And you can do the same thing here. If you have 3%, that's 3 over 100. And then if you plug that into a calculator, 3 divided by 100, you get 0.03. And so we get 3% equals 0.03. And our guy over here, last one, 1.2% equals 1.2 over 100, which equals 0.012. And then so if you just write this, skip over that middle piece, you're going to get 0.012. Okay, and there's a consistency to all three of these. If we think of the decimal point as being here for 70%, here as being for 3%, and right there for being 1.2%, to move from here to here, what we ended up doing is we ended up moving the decimal point 1-2 spots to the left. From here to here, 1-2 spots to the left. From here to here, 1-2 spots to the left. So to convert from a percent to a decimal, you move the decimal point 2 places to the left. Okay, and then so let's go ahead and keep going. So the next thing we're going to look at is how could you go through and use percents when you don't have something that's over 100. So like, let's say we wanted to go through and take, you've got the 2 men with long hair over the 5 total men. And we wanted to go through and ask ourselves, okay, what percent of men have long hair? What percent of the total men have long hair? To go through and answer that, what you need to do is you need to rewrite this so that it has 100 in the denominator. So there's a couple ways you can do this. So one way, I've kind of already given it away here, is you can use a proportion, right? So if we want to have 100 in the denominator, you can go ahead and just use that method that we just used a few minutes ago, put an X here up top, and then you're going to get 200. You're going to get 2 times 100 equals 5 times X. And then if you go through and divide both sides by 5, you're going to get 40. All right, and so you could go through and then say, so 2 men with long hair is out of 5 total men is equivalent to 40 men with long hair per 100 men, which is 40%. As soon as you've got the part over 100, you can go through and you can rewrite it as a percentage. So say 40% of men have long hair. Or in this case, not in real life, but so that's one way to do it. The other way to do it is actually to go through and use, I think an easier way to do it is to go through and use decimals. So if we've got our 2 men with long hair over 5 total men. Then if you go through, and again, this is part over whole, so we could divide these to get 2 over 5. That's going to be equal 0.40. And then from 0. So again, this is just using a calculator. 2 divided by 5, you get 0.40. And then we can convert that into a decimal by moving the convert that into a percent by moving the decimal 2 to the left. Sorry, doing that. So we can convert. All right, let's go back. I actually skipped over that. It didn't occur to me I skipped over that explanation. So to go from a percent to a decimal, you move the decimal place 2 to the left. If you're going to go from a decimal to a percent, then you've got to move the decimal point 2 to the right. Okay, and so if we're going to go this way, then we would move this 1, 2 to the right. If we're going to go this way, then we would move 1, 2 to the right. And so in this case, we have the decimal and we're converting it into a percent. So we want to move it 1, 2 to the right. I apologize for that. I did not make that clear. Okay. And so you could use the same thing here. If you have the 7, what was the example I used earlier? Seven women always wear seatbelts. Out of 10 total women. So you could go through and just take 7 and divide it by 10. If you do that, you get 0.70. And then to convert from decimal to percent, you move the decimal point 2 to the right, 1, 2. So we get 70%. So we could say 70% of women in this case wear seatbelts. Okay. And so that gives us a nice intro for percents. All right, next, we can also go through and take this part over whole equal percent, and we can use it to create equations that we can solve. All right, and so the reason we would do that is that if you go through and turn this into an equation, then given any 2 of these, you can go through and solve for the third. All right, and so a common equation that you'll see is instead of seeing part over whole equals percent, you'll see people go and take the whole, like multiply this, but both sides of this by whole, and they'll rewrite it into part equals percent times whole. So sometimes you'll see this instead. These are equivalent, and you can use whichever one you're more comfortable with. So if you want to write it as a fraction like this, part over whole equals percent, you can do that, or you could go ahead and rewrite it into this equation that doesn't have fractions, where you've got percent times the whole gets you the part. All right, so let's go ahead and take a look at how you could use this. So we say if a study has 300 people, and 30% do not always wear seatbelts, then how many people do not always wear seatbelts? Oops, not seat belts. Okay, and so in this case, what you need to do is just from reading comprehension, you have to determine, are they giving you the whole and asking you for the part, or are they giving you the part and asking for the whole? So in this case, if you go through and read, if a study has 300 people, if a study has 300 people and you have some of them who are wearing seatbelts, then 300 people is the whole, and they're asking you to go through and find the part. So there's a couple ways you could do this. You could either go through and do X over 300. So that's part over whole equals 30%. Or you could do X equals 300. Oops, sorry, hold on. X equals 30% times 300. And these are pretty much the same thing. If you go through and convert 30% into a decimal, you can then go through and solve this. So you get X over 300 equals 0.30. And so in this case, we move the decimal point 2 to the left. So if we're going from percent to decimal, it's 2 to the left, decimal to percent, 2 to the right, the opposite. Okay, and then once you're there, you can just multiply both sides by 300 and you'll get 90. And of course, the same thing here. If X equals 0.30 times 300 equals 90. Okay. Let's look at another quick example just like that. If a study has 17 people, that always wear a seatbelt, and this is 85% of the total, then how many people are in the study? Okay, and so again, you can use that, part over whole equals percent. That's kind of the method that we're using here. And so in this case, so from reading comprehension here, we got if a study has 17 people in it, and this is 85% of the total, how many are in, what's the total? So clearly 17 is the part in this case, and they're asking you to find the whole. So you would do 17 over X equals 85%. Or if you prefer the other way, it's 17 equals 85% times X. Okay, and then from there, you just go through and convert 85 into 0.85 by moving the decimal point 2 places to the left. And then you can go through and multiply both sides by X, divide both sides by 0.85, and then punch that into a calculator and you should get X equals 20. And a similar set of steps over here, 17 equals 0.85x, and then 17 over 0.85 equals x, and then x equals 20. Okay, so that's kind of gets us started on percents, but percents are actually a really, well, not really, they're a complicated subject. If I say really complicated, it's something that's not intimidating. It's a complicated subject. There's lots of different cases for percents. And so we start off with part over whole, but that's not the only case for percents. Percents are also used with a baseline instead of a part over whole. okay? And so this is kind of the case where if you've ever heard of percents, percents can be over 100%. And so that's typically not going to be when you have a part over a whole, because usually the part is going to be smaller than the whole. But you can have percents where if you think of the whole instead of as a baseline, as like kind of an initial starting point, then you can end up with a number that is bigger than the baseline, which would end up with something that's over 100%. All right, so we're still gonna go through and use a ratio for this. What we're gonna do is we're gonna have the comparison quantity in the numerator over the baseline, and then have that equal the percent. Okay. So let's see this in action, with an example. I think that's probably the best way to explain it. If sales are 300 units this year, and we're 200 units last year, what is the percent change from last year to this year? Okay, so in this case, we're not looking at part over whole. It's not that 300 is some part of 200. The two quantities are not related in that way. So this is just a different application for percents than the part over whole application. Okay, but instead, what we're going to do is this is a comparison with a baseline application for percents. And what you want to do is you want to figure out what's the comparison quantity to put in the numerator, and then what's the baseline to put in the denominator. Okay, and so if you go through just reading cover, there's 300 this year, 200 last year. What is the percent change from last year to this year? So in this case, the starting point is the baseline. So if you want to think about what's the starting point, where did you begin in this case? You began last year, and you want to see how things changed from last year to this year. So the starting point, or the baseline, is going to be the quantity from last year. And so you want to have 200 in the bottom, and then the comparison is then the new amount, which is 300. And then you're asked, what is the percent change? If you go through and take this and plug it into a calculator, you get 1.50. Rewrite that by moving the decimal point 2 to the right, which is how we go from decimal to percent, and you get 150%. Okay, so the percent change from last year to this year is 150%. And the way that you could write that, sales are 150%. So sales this year are 150% of last year. Okay, let's look at another example. If a study has 50% the number of men than it does women, And there are 30 women in the study. Then how many men are in the study? Okay. So, so one thing when if you go through and this is some information that you need to know to go through and figure this out. If you see a phrase like the number of men than it does women, so you have 50% the number of men than it does women, the second quantity is going to be the baseline, and the first quantity, so that the first thing that it's describing is the comparison, and the second thing is the baseline. So if this had said the number of women than it does men, then men would have been the baseline and women would have been the comparison quantity. Right. And so that's just the way that the language works, is if you see, something like 50% the number of men than it does women, then that the women is going to be the baseline and men is the comparison quantity. Okay. And so if we start off with that, right, so we've got 50% the number of men than it does women. So we're going to say this equals 50%. And then the goal is just to figure out what goes over here on the left-hand side. And I just told you what it is. And that is that it's going to be women in the bottom and men in the top. Okay. And that's just the nature of the language here of this phrase. If you see the number of something, then it does something else. The second one is the baseline and the first one is the comparison. So we've got men over women equals 50%. If we just keep reading, and there are 30 women in the study, so you're going to have, that means you're going to have X over 30 equals 50%. All right, and then so from there we can do X over 30 equals 0.50 by converting our 50% to a decimal by moving the decimal point 2 to the left. And then from there you can just multiply both sides by 30 and you'll get 15. All right, so there are 15. If a study has 50% the number of men than it does women, and there are 30 women in the study, then there are 15 men in the study. Okay. All right. So that's the first introduction we have to percents with this idea of a baseline, but we're going to keep going. There's more ways to use percents than that. So we're going to extend this idea of percents with baselines to include some additional phrases that you'll see used with percents, and that is percent increase, percent larger, percent more than, and other similar phrases. So we're going to look at percent increase, percent more than, and percent larger. Okay, so the difference between these cases that we're talking about with these percent increase, percent more than, and percent larger is that we need to put in an adjustment for whether to include or exclude the baseline. So the difference between these three and the previous examples is that you need to put in an adjustment for baseline. Okay. And so the way that I'm going to go through and kind of give you a formula for that is that it's just a little bit different than the last one. So you've got the comparison quantity, it's still in the numerator, over the baseline. Let me just use the tool. It's hard to draw a straight line with this. Over the baseline equals the percent plus 100%. Okay, so the 100% in this case represents the fact that we're going through and we're including this right here, this 100%. It represents including the baseline. Okay, in the calculation. Let me just give you an example for that to make sense. Like, start to say, try to explain that again, but I think it's clear with an example. All right, so if sales are 300 units this year, and we're 200 units last year, then what is the percent increase from last year to this year? Okay, so there's a couple ways to do this, and I'm going to go ahead and I'm going to do it. First, the first way I'm going to do this is going to be different than the way that we've solved these recent problems, but it's going to illustrate what I mean by this idea of including or excluding the baseline in the calculation. All right, so if sales are 300 units this year and we're 200 units last year, we want to know the percent change. So if you're going to exclude the baseline in the calculation, then what you do is you subtract it. So you go through and you do 300 minus 200 equals 100 new units. Okay, so if there were 200 last year and there are 300 this year, then you added 100. All right, so the amount of increase was 100 units. And then to go through and figure out the percent increase, you take the 100 new units and you divide it by the amount from last year, the baseline. Okay, and then you go through and you calculate what that is. So 100 over 200 is going to be 0.50, which is 50%. So we'd say there's a 50% increase. Okay, in the number of units sold. So that's not how I'm going to go through and do the problems normally. I'm just showing you a way to do it that really highlights the fact that the percent increase, you've got to go through and you've got to remove the baseline from the change from the change in quantity to go through and calculate the percentage. Okay, so that's one way to do it, but that's not how I'm going to do it. Instead, what I'm going to do is I'm just going to use this formula up here because it just makes things a lot simpler. All right, so our comparison quantity is 300. Our baseline is 200. We want to know what percent increase that is plus 100%. So I'm just copying this down as a formula. This 100%, it represents the 200 in the previous problem. Okay, so if you can see that happen, right? So watch this. So you do 300 over 200. If you go through and calculate, that's 1.5. All right, and then we're going to leave this percent alone just for the moment. And we're going to change the 100% to a decimal. And the way that you change it to a decimal is by moving the decimal point 2 to the left. And so we get 1. And then if you subtract 1.5 from 1, you get 0.5 equals the percent. Okay, and if you write that as a percent, that's 50%. So you get a 50% increase in units sold. So you can do this either way. These are both correct. There's nothing wrong with this one. So if you're going through and finding percent increases or percent more than or percent larger, one way to do it is to go through and take the quantity that you're comparing to, subtract it from the baseline to figure out how much change there is between the two, and then divide by the baseline when you're done, and that will give you the percent increase, the percent change. Okay, or you could just use this formula that we came up with that includes this 100%. That 100% is it's the equivalent of doing this. Okay, it's the equivalent of that 200 units. Okay, in here, and so the math just ends up working out very similarly. You end up getting the same result. So I think this is a bit simpler, and so this is how I do it. And so this is how I will do it typically in videos. Is I'll go through and I'll compare the two quantities, and then I'll set it equal to percent plus 100%. Okay, let's take a look at another example with that. If a study has 50% more men than women, and there are 26 women in the study, then how many men are in the study? Okay, so more, that's similar to percent more than. So that does cover this case. So if a study has 50% more, so the difference between this example and the last one is the last one said if a study has 50% the number of men than women, how did I describe it? The study has 50% the number of men than it does women versus 50% more men than women. And these are two different cases, and you need to go through and handle them differently. Okay, so if you have 50% more, then you need to go through and use this method as opposed to the previous one. Okay, and so just like the last example, so what we're going to have is we're going to have our comparison quantity over the baseline equals the percent plus 100%. Okay, and so in this case, but just from reading from what I said in the last example, if you've got 50% more men than women, the number of women is the baseline. The thing that occurs second is the baseline. So that's going to be in the bottom. And then the number of men is going to be the thing that we're comparing. And so in this case, you're going to say X, that's the number of men. That's what we're trying to find. The baseline is the number of women, which is 26. That equals the percent, which is the 50%. That's what they gave us. That's 50% plus 100%. And so you get X over 26 equals 150%, which if you write that out, that's 1.5, right? Change that to a decimal, it's 1.5. And then you'll get X equals 26 times 1.5, which equals 39. All right, so that means there'll be 39 men in the study. Okay, so if a study has 50% more men than women, then that means that you need to take the number of women and multiply it by 1.5. You need to add 100% to the percent that they gave you and then multiply by that. And once you get some practice, you can just do that in your head. So if something is 70% more, then that means you need to multiply by 1.7. If something is 5% more, then that means you need to multiply by 1.05. So you need to add a 1. And that's what the 100 here is. It's the 1 that you're adding to the percent to get more than. If you don't have more than, if it's just 50% the number, then that means you don't add the 1 and you would just multiply by this as a decimal. You just multiply by 0.5. And so 30 times 0.5, that gets you 15 versus 26 times 1.5. So the more, we just add the 1. If the more is not there, then you don't add the 1. Okay, and so that's the difference between the two. Okay, hopefully that makes sense. And then the last case we're going to look at is percent decrease. Percent less. And percent fewer. Okay, and this is very similar to the last case. It's a bit different, but it's a little bit similar. You have comparison over baseline equals a negative percent plus 100%. Okay, so it's the same thing except the percent is now negative. That's going to give us a percent decrease, a percent less, or a percent fewer. So to stick with the examples we've been doing, if sales are 75 units, this year, and we're 200 units last year, then what is the percent decrease? From last year to this year? Okay, and so if you again kind of go through and take a look at this, the baseline is we're comparing to last year. So last year is going to be the baseline. So we're going to have 200 in the denominator. The thing we're comparing is the 75. So you've got 75. And then we know we want to have a negative percent plus 100%. And we're trying to figure out what that negative percent is. All right, so to go through and do that, you want to take 75 and divide it by 200 using a calculator. You'll get 0.375 equals negative percent. And then 100, we're going to convert to a decimal. That's going to be plus 1. Then you want to subtract the 1 from both sides, and you're going to get negative 0.625 equals negative percent. We're trying to find. The negatives here can cancel, and so then we're going to have 0.625 is the percent that we're trying to find. And so this is 62.5%. If you go ahead and move the decimal point 2 to the right, which is how we convert from a decimal to a percentage. All right, so the way that we would answer this question is that there was a 62.5% decrease from last year. Okay, and so this is hopefully this is a consistent method. We're going through and using the same technique. Now you can go through and kind of do this in your head a little bit like the example that like the examples that I was giving for the previous cases where I said, you go through and if you take this and if you're trying to find percent more, then you need to add a 1 here, and then you can just take and multiply by by 1.5, which is 150% as a decimal. What you could do here is you to do this in your head, it's 75 over 200, and then you subtract 1. Okay, so instead of adding 1, you subtract 1. So it's the opposite. Oh, and just to be clear here, it's not a negative 62.5% decrease. It's a positive 62.5% decrease. All right, and then let's look at one more here. If there are 30% fewer men than women in the study, and there are 30 women in the study, how many men are there? Okay, and so we can go through and use the same method. We've got our comparison over the baseline equals the negative percent plus 100%. Okay, so the comparison, that's what we're, that's the unknown here. That's the number of men. And how do I know that? It's because as soon as you read 30% fewer men than women means that that's the baseline. The thing that comes at the end of kind of this phrase here, that's the baseline. So it's the same thing. It's consistent throughout, right? We did the same thing, with this case. It's more men than women. So women was second. That's why that was the baseline. And it's consistent with this case too, 50% the number of men than women. Okay, so women is going to be the baseline. Whatever comes second is going to be the baseline. And so we're asked to go through and find the number of men. We don't know the number of men, but that's the thing we're comparing. The baseline is the number of women. That's going to be 30. And then you've got the negative, the percent that's given. So you've got negative 30% plus 100%. And so you get x over 30 equals 70%. And so if you convert that into a decimal, x over 30 equals 0.70 by moving the decimal point 2 places. And then you get x equals 21. Okay. And so the shortcut for trying to go through and do this, like if you're going to try and do it in your head, is that anytime you hear 30% fewer, 20% less, or a 15% decrease, then what you want to do is you want to go through and take the number here that they gave you and you want to subtract it from 100. So 30% fewer means that there's going to be 70% the number of men than women, 70% the number of men than women. If this were, if you go to the store and you want to buy something and something is 20% off, then what you do is you take 100%, subtract 20%, and the price is going to be 80% of what is listed. Okay, and so that's the way that you can go through and handle fewer, less than, decrease. You want to take the quantity, subtract it from 100, and then you can go ahead and multiply by that. That's what you're going to end up doing. That's what this formula does. It takes the quantity, makes it negative, and then subtracts it from 100, or adds a negative value plus 100. Okay. And so I think that's all the cases for percents. I sat down and I tried to think of all the different cases that you'd use it in. And so I think I've got all of them. You can let me know if I've missed any in the comments. And hopefully that's it. Thank you for watching, and I'll see you next time.